So I've got the syllabus calendar pulled up here. I just handed back test 2 and quiz 4 and project 2. So I just managed to get everything graded like 5 minutes before class started. So I didn't do a progress report as of test 2, but I will bring you one on Wednesday. So today we're going to start talking about quadratic functions. You don't have any sort of assessment, quizzes, tests, projects due until the 18th, okay, of November. So we got a couple weeks of material, and then you'll have a quiz due, and then you'll have a project due. All right, so let's look at the preview exercises together. So the general form of a quadratic function is any function that can be written as f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not 0. Okay. It's different from a linear function because it contains an x squared term, right? If I covered up the x squared term right here, I just have bx plus c, which would be a line. B would be the slope of the line, c would be the y-intercept. So when you add this squared term, we call it a quadratic function. The graph of any quadratic function is called a parabola. It looks like a U, and it either opens upwards or downwards. So the parent of all quadratic functions is f of x equals x squared. The point 0, 0 at the origin is called its vertex. That's sort of the turning point, the local minimum point. It's called the vertex. So I want to graph the function 2 times x minus 1 squared minus 3 by transforming the graph of x squared. So I'm going to determine where some key points go when we transform the graph of f into the graph of g. So I have to know what each of these transformations do. Right? The 2, the minus 1, and the minus 3 each change the points somehow. What does the 2 do? Multiply the y-coordinate. It's not being squared. It's outside of the squaring. So that means it's changing y. And it's going to double the y-coordinates. Okay. So first thing I'm going to do is double my y. So I have negative 3, 18, negative 2, 8, negative 1, 2, 0, 0, 1, 2, 2, 8, and 3, 18. So I just doubled every y-coordinate because of that 2 that's outside. All right, what does that minus 1 on the inside tell me to do? Add 1 to the x value. It says move right 1 unit because it's inside, and those are always kind of the opposite of what you think. So that's changing x because it's inside, it's affecting x. But I have to actually add 1 to each x coordinate. So this is going to become negative 2, 18, negative 1, 8, 0, 2, 1, 0, 2, 2, 3, 8, and 4, 18. Okay, so just added 1 to each x. That moves everything to the right one. And then that minus 3 that's outside, what does that tell me to do? Subtract 3 from the y values. That represents a transformation, a shift down by 3 units. So to do that, I'm going to subtract 3 from every y. So I get negative 2, 15, negative 1, 5, 0, negative 3, nope, 0, negative 1. Yeah, okay, I'm sorry. So it was 0, 2, right? And it's going to become 0, negative 1 when I subtract 3. Okay, 1, 0 becomes 1, negative 3. 2, 2 becomes 2, negative 1. 3, 8 becomes 3, 5. And 4, 18 becomes 4, 15. So I just subtracted 3 from every y coordinate. Okay. So let's plot these points. Negative 2, 15 does not fit on my graph. let's see, -1, 5, I can plot that. 0, -1, 1, -3, 2, -1, 3, 5, and 4, 15 is off of my grid, but I think I have enough here to be able to see the U shape. All right, so where did my vertex move to? What are its coordinates now? 1, -3. Yeah, so it was at 0, 0, and now it's at +1, -3. Okay. Could I have identified the coordinates of the vertex, that 1, -3, just by looking at this equation? Mm-hmm. Yep, there's the 1, there's the -3. What role does the y-axis play in the graph of the original f? Right, so here's f. What role does the y-axis play? It's a special line for the function x squared. I do know. Yeah. Do you? So it's acting like a mirror, right? So it's the left half and the right half are mirrors of each other, and the line, the y-axis is a line of symmetry. Yeah. So we call it the axis of symmetry. And that axis of symmetry moved when we created our new transformed function. It moved over here to the line x equals 1. And this green one, that's the equation x equals 0. So they are both axes of symmetry. All right, so here's my teaching demo. The standard form of a quadratic function is a times x minus h squared plus k, right? So that's what I was just looking at up here. I was looking at something in that form, this g of x. Oops. My a was a 2, my h was a 1, my k was -3. So my general form is a times x minus h squared plus k. So what transformations from the graph of x squared does the standard form represent? Yeah, it's a parabola. What does the a do to x squared? Mm-hmm. Yeah, it stretches or shrinks it. Yeah. What does the h do? Left and right. Yeah, moves it left and right, depending on the sign of h. Yeah. And what does k do? Up and down. Yeah. Okay, so what can we tell looking at the standard form? If you just have this equation just with a quick glance, you can figure out what its vertex is, right? The standard form is convenient because it immediately identifies the vertex as h comma k. So you can just pick out those numbers and you know the vertex. And then the leading coefficient a tells us whether the parabola opens up or down, right? Because if you multiply all the y values by a positive number, all the y values will get bigger, and so it will open up. Yep. But if you multiply all the y values by a negative number, it's going to take regular old x squared and it's going to flip it over the x-axis, so it will open down. So when a is big, or when the absolute value of a is big, that makes the parabola narrower, whereas when the values of the absolute value of a are small, that makes the parabola wider. And when you're trying to make an accurate sketch, it can also be helpful to find the x and y intercepts, right? In general, to find a y-intercept, you make x0 and solve for y. To find a x-intercept, you make y0 and solve for x. All right. if we let the leading coefficient get closer and closer to 0, like if I have ax squared plus bx plus c, right? That's a different form, but equivalent to the one we were just talking about. If you let this value of a get very close to 0, get teeny, teeny, tiny, what happens to the quadratic function? Yeah, the quadratic term is going to get really close to 0, because when you multiply by something that's really small, the whole thing gets really small. It actually will open. Yeah, it will open, and it'll look more and more like a line, because this term will be closer and closer to 0. And then when it is 0, it's a line, right? So if that's 0, then you get y equals bx plus c. So it looks more and more like a line. On A, it just gets really, really wide, like wider and wider and wider and wider. And when it hits 0, it'll be like line. Okay, so we have two forms. We have the ax squared plus bx plus c form, and we have the standard form, a times x minus h squared plus k. Now, your book never gives this form a name. Would you like to name it so that we can refer to it as something? What should we name it? How about alphabetical form? Okay. So standard form is the one with the H's and the K's and tells you the vertex. We'll call this one alphabetical because the A, B, C coefficients. So we'll call this alphabetical form. Just makes it easier to talk about the two forms. So I want to be able to convert between the two because they are completely equivalent. It's just two different ways of writing the same thing. Just like when we did lines, there was slope-intercept form and point-slope form. They're totally equivalent. There's two forms for quadratics too. Okay, so there's an A in both forms, right? So that's handy because it's the same, right? The A in alphabetical form is the same as the A in standard form. So that part's easy. But now we just need to identify H and K, and we'll have everything we need. Okay. So it turns out that the vertex of a parabola, defined by the quadratic equation ax squared plus bx plus c, its x coordinate is negative b over 2a, and then you take that x coordinate and plug it into f, and that gives you the y coordinate. Okay, so h is negative b over 2a, and k is f of negative b over 2a. Negative b over 2a, does that remind you of anything? Sound kind of familiar? The quadratic formula, and that's exactly where it comes from. I'm not going to derive it for you because it's not really worth our time, but know that that's not just some magical thing. It comes from the quadratic formula. All right, so let's do an example. I have a quadratic function in alphabetical form, negative x squared plus 4x plus 1, and I want to change it to standard form and then graph it. Okay, so the vertex of this parabola, well, h is the x coordinate of my vertex. That's going to be negative b over 2a. Okay, so what is b in my alphabetical form here? 4. So I'm going to have negative 4 over 2 times negative 1, 2a. So it's negative 4 over negative 2, which is 2. And then k, which is the y coordinate of the vertex, you get by taking the x coordinate of the vertex, 2, and plugging it into the original function. So k is just f of whatever you found out h was. So f of 2. If you plug a 2 in here, 2 squared is 4, make it negative, you get negative 4. Negative 4 plus 8 is 4, plus 1 is 5. So my vertex is at 2, 5. And now that I have the vertex, I can write it in standard form. Right, so I'm just going to write out the general equation for standard form. That's a times x minus h squared plus k. And then I'm going to go ahead and replace a, h, and k with numbers. Okay, so what is a? -1. Yeah, because a in alphabetical form and a in standard form is the same a. So up here we have a is -1. Right, so I'll put a -1 there. X minus, what should I put in for h? 2. So the minus is part of the formula, right? So I copied the minus sign. And then for h, I would just put in a 2 squared and then plus k, which is 5. Does this parabola open up or down? Down, because a is -1. Find the y-intercept. In general, to find y-intercepts, you plug 0 in for x. And I could use my original function or my standard form. It'll give me the same thing because they are equivalent. So if I plug a 0 into my original here, I get 1. Five is find the x-intercepts of the parabola, if there are any. So that means in general, you want to take your equation, -x squared plus 4x plus 1, set it equal to 0, and then we would solve it. How would I solve that? No. How do you solve? Either factor it or the quadratic formula. Yeah. So I don't think that this factors. So let's see, if I do the quadratic formula, I get I'm going to do a little trick. So this is -x squared plus 4x plus 1 equals 0. Equivalently, I could set my other equation equal to 0 and solve it because they are the same. They're totally equivalent. So I could do -1 times x minus 2 squared plus 5 equals 0. Those two formulas are the same. So I'm going to do a little trick. We did learn this. We just don't use it very often, but I did present it when we solved quadratic equations. So I'm going to try to isolate just the x minus 2 squared. So subtract 5 from both sides, and I get -1 times x minus 2 squared is -5. Divide both sides by -1. So I get x minus 2 squared equals 5. And then how do I undo squaring? Square root. So x minus 2 is plus or minus the square root of 5. And then add 2 to both sides. So x is 2 plus or minus square roots of 5. And then I can get an approximate value for that if I want. Okay, so let's see. 2 plus square root 5 is like 4.2. Write it over here. X is approximately 4.2, or minus, and I get -0.24. Okay, so next thing, the last thing I'm going to do is graph it. So I'm going to go through and plot my points. My most important point is the vertex 2, 5. And I know it opens down and my y-intercept is at 1. And I know my x-intercepts are at -0.24 there and 4.2 there-ish. And then I know it opens down, so I can connect these. Nice smooth curve. Okay, what if I want to change back? What if I gave you y equals -1 times x minus 2 squared plus 5, and I said, here's standard form, put it in alphabetical form? What would I do? Sure, okay, so Cassandra said either FOIL or multiply by -1. Which should I do first, squaring or multiplication? According to PEMDAS. Squaring, yes, I'm going to square x minus 2 first. So this becomes y equals -1 times, when you FOIL x minus 2 times x minus 2, you get x squared minus 4x plus 4. Then distribute your -1, so you have y equals -x squared plus 4x minus 4, and still have the plus 5. And then just combine your like terms at the end there. The -4 and the plus 5, and you get y equals -x squared plus 4x plus 1. And is that the formula I started with? Yes, -x squared plus 4x plus 1 was the thing I started with at the very beginning. So now I can go in both directions. If I give you standard form, you can change it to alphabetical. And if I give you alphabetical, you can change it to standard. Okay. So either way, either form I give you, you can draw the graph, right? Because if I give you alphabetical, you can change it to standard, and that makes it easy to draw the graph. But what if I give you a graph and ask you to come up with an equation? So here's a graph of a quadratic function. I want to write both forms, standard and alphabetical. Okay. Standard and alphabetical form. All right, so let's start with standard because they gave me the Vertex 3.5. And so that means I'm 2/3 done with standard form, right? I know H and K. So I'm going to write down the standard form, the general form of it. They gave me H and K, the vertex. So I don't know A yet, but I know that H is 3 and K is 5. Okay. So I know all but one thing. What can I use to figure out that A value? Yeah, a point, the coordinates of a point. It's just like when you're doing an equation of a line. Once you know the slope and you go, okay, y equals 3x plus b, how do I figure out b? Use a point, right? Once you only have one thing left to know, you can plug in a point. So I could use either 0.23 or 6.23, doesn't matter. I think I'll use the 0. You can't use 3.5. That won't be helpful because when you put a 3 in for x, you're going to get a 0 there. So a times 0 will go away and a will be gone from your equation. And the idea is to try to solve for a. Yeah. So let's see, if y is 23, don't know a, I'm going to replace the x with a 6. So I'm using this point here. And then I have 23 equals 6 minus 3 is 3 squared is 9. So this is 9a plus 5. Subtract 5 from both sides, I get 18 equals 9a, which means that a equals 2. So I'm almost done. My final equation is going to be y equals, I'm just plugging into the standard form, replace the a with a 2. the h with a 3, and the k with a 5. And x and y should stay x and y, because those are the variables. All right, so that's my standard form. And then to also write it in alphabetical form, just square the x minus 3. So I copy the 2 down. X minus 3 times x minus 3 is x squared minus 6x plus 9. And then distribute the 2 and combine like terms. So I have 2x squared minus 12x. 2 times 9 is 18 plus 5 is 23. What do you think? Cool? All right. I like that answer. Okay, so you've got some stuff to work on. I will be around to help if you need it.